Okay, we got the notes for section 6.6, which deals with the Moivre's theorem and nth roots. So we first start talking about the complex plane. So every complex number can be associated with a point in the complex plane. Real numbers are placed along the horizontal axis, so your real axis. Imaginary numbers are placed along your imaginary axis. The complex number a plus bi has this point here, so over a on the real side, bi, so up on the imaginary axis. So plot u, v, and u plus v in the complex plane. These 3 points and the origin determine a quadrilateral. Is it a parallelogram? All right, well, let's see here. So 1, 3i would be 1, 1, 2, 3. So there's 1 plus 3i. This is the real axis. This is the imaginary. 2 minus I, so that'd be over 2 down 1. Be right there. U plus v, well, 1 plus 2 is 3 units over, 2 units up. So you got that. So you got this lovely shape right there. Is that shape a parallelogram? Yes. Okay. Definition, absolute value of the modulus of a complex number is essentially the distance from the origin on the complex plane. So a squared plus b squared would calculate the distance to any point a comma b. So from the origin. Okay, polar form of complex numbers. So you can write complex numbers in trigonometric form. So z is a plus bi can be written this way. Z's r cos theta plus I sine theta, where these things are true. A is r times the cos theta, b is r sine theta, so on and so forth. R is the absolute value of the modulus, theta is the argument of z. So use an algebraic method to find the polar form between 0 and 2 pi for the complex number, approximate exact values. Okay, so we need to find the value for r, but r is equal to the square root of a squared plus b squared. It's right there. So this is the square root of 1 plus 3, which is the square root of 4, which is just 2. Theta is the inverse tangent of b, negative root 3, over a, which is 1. And that's going to occur at, let's see here. So where is the tangent negative root 3? That occurs right here at pi over 3 radian. So z equals 2 quantity cosine pi over 3 plus I sine pi over 3. And that's your answer. You don't go any farther because that's the form that you want it in. So there you go. Oh, that's the wrong angle though. 1 negative root 3. That would be down here. Over 1 down. So it actually should be 5 pi over 3. Add 180 to it to get across. All right, this one. So r is equal to the square root of a squared plus b squared, so root 9 plus 16 is root 25, which is 5. Theta is the inverse tangent of b over a, which, let's work in, we'll work in radian. So the inverse tangent of 4/3. So your calculator will give you this value, but that value is in quadrant 1. I need to be in quadrant 3, so I need to add pi radian to flip it around. So it's about 4.07. So you have to be careful. If you're over these 2 quadrants, you have to add, if your point should be over here, you need to add 180 to the angle that you're given, because it's always finding the opposite one. So my answer would be z equals 5 cos 4.07 plus I sine 4.07. And once again, don't distribute that back out because then you'll just end up back where you started. All right, so the reason we sometimes use trigonometric forms of complex numbers makes doing products and quotients a little bit easier. So if you have 2 complex numbers, z1, z2, If you multiply them together, you multiply r's, add angles. If you divide them, you divide r's, subtract angles. And that's all there is, assuming that your second radius isn't 0, because then it doesn't work. Okay, so example 3, use an algebraic method to express the product of z1, z2 in standard form. All right, so since I'm multiplying, that's going to equal r1 times r2, quantity cos theta 1 plus theta 2 plus I sine theta 1 plus theta 2. So multiplying my r values together, r1 times r2, so 12, or 25 times 12, so this would be 300 root 2. Negative pi over 4 plus pi over 3, well, negative pi over 4 is the same thing as negative 3 pi over 12. Pi over 3 is 4 pi over 12, so these angles are pi over 12 when I add them together. Okay, so then since it was in standard form, I actually need to work out my distributing. So make sure I'm still in radian. Yep, okay. So the first part, 300 square root 2 times the cosine of pi over 12 is 409, we'll call it 0.81. Plus, and then the same thing, so 300 square root 2 times the sine. Notice I left the I out because I'll just put that back in at the end. So 109.81. I just goes back at the end. Okay, so there we go. All right, so for 4, express the quotient in standard form. All right, so that should be Z1, that's the exclamation point. So Z1 over Z2 is equal to R1 over R2, cosine theta 1 minus theta 2, plus I sine theta 1 minus theta 2. So that's going to be 2 root 2 over 6 cosine. So the difference in these angles is going to be negative 165 degrees. (135 minus 300), and then distribute. So calculator goes to degrees. So 2 square root 2 divided by 6 times the cosine of negative 165 is negative 0.46. 2 square root 2 divided by 6 times the sine of negative 165 is negative 0.12, and I. So there you go. Okay, you can also use de Moivre's theorem to find powers. So let z, r, cos theta, I sine theta be a positive integer, then this happens. So if you raise a complex number in trig form to a power, you raise the r value to a power and you multiply the angle. So the first thing I'm going to do is I'm going to convert this, because otherwise I don't want to work that FOIL out. So r is the square root of 1 squared plus root 3 squared, which is the square root of 1 plus 3, which is going to be just 2. Theta is the inverse tangent of b over a, which would be at pi over 3 radian. So what I actually have is 2 cosine pi over 3 plus I sine pi over 3, all raised to the third. So the exponent goes on my r value, and my angles get multiplied by the exponent. So 8 cosine pi plus I sine pi. So then I can work this out. The cosine of pi is negative 1, so that's negative 8. The sine of pi is 0, so my answer is just negative 8. And that's as far as I need to go. All right, example 6. Find this thing. All right, so this would be a hot mess if we go to the 8th power, so that's a lot of distributing to do. So r is equal to the square root of a squared plus b squared. So this is the square root of root 2 over root 2, or sorry, root 2 over 2 squared becomes 2 over 4. So it's 1/2 plus 1/2. So all this is just 1. Theta is the inverse tangent of root 2 over 2 over negative root 2 over 2, which is the inverse tangent of negative 1, which is, for your calculator, negative pi over 4. But this angle should be 180 across, so we'll make it 3 pi over 4. So we can do z equals, I don't see. So bracket 1 cosine 3 pi over 4. No parenthesis there, plus I sine 3 pi over 4, all raised to the 8th. So 1 to the 8th cosine 3 pi over 4 times 8 plus I sine 3 pi over 4 times 8. So 1 to the 8th is 1. 3 pi over 4 times 8 is 6 pi. Notice these angles will always be the same. Okay, so the cosine of 6 pi is, well, let's see, 0, 1, 2, 3, 4, 5, 6, so it's 1. And that's 0. So this whole thing just comes out to be 1. All that work for just 1. You can also do it to your roots, because remember, root is just a fractional exponent, except you have more than one of them. So here's how you find the nth roots of complex numbers. So nth root of r. Now, you have this 2 pi k term where k starts at 0 and counts up to 1 less than your root. So if you're doing the 4th root, you do k 0, 1, 2, 3. And then you work them individually out. So let's see here. Find the 4th roots of this thing. So I'm trying to find 4th root of 5 cosine pi over 3 plus I sine pi over 3. So I need to do k values up to 1 less than that. So I do k is equal to 0, I do k is equal to 1, I do k is equal to 2, I do k is equal to 3. So what that's going to look like is this, following that formula from the previous page. Let's see if I can get it. I don't think I can get them both on here. So it's the nth root of r. So it's the 4th root of 5, because that's my r value, parentheses, cosine, so my theta, pi over 3, and then it's plus 2 pi k. Well, k is 0, so it's going to be plus 0 all over n, which is the root, so 4, then plus I sine, and the angle here is going to be the same. So for k1, 4th root of 5, cosine pi over 3 plus 2 pi over 4. Because it's always going to be a multiple of k. There's k times 2 pi here. Plus I sine. For 2, 4th root of 5, cosine pi over 3 plus 4 pi over 4. Plus I sine pi over 3 plus 4 pi over 4. 4 root 5, cosine pi over 3, plus 6 pi all over 4. So that would be essentially how it works out. And then you can, of course, simplify some things. So this one is 4 root 5 cosine pi 12 plus I sine pi over 12, because the 0 goes away. So on and so forth. This one, 4 root 5, would be cosine, this is going to be 7 pi over 12. The next one would be 13. And the last one will be 19. Now, once you have the first two, it's you can shortcut doing the rest of these without having a common denominator or everything else. Because this difference is 6/12, so they're all going to differ by 6/12 moving down. All right, find the cube roots of -1 and plot them. So we need to write -1 in polar form. So z equals -1, that's the same thing as -1 plus 0i. So r equals the square root of -1 squared plus 0 squared, which is just 1. Theta is the inverse tangent of 0 over -1, which would be 0, but that is the wrong direction. We need to be left, so we need to add pi. So our theta value is pi. So cube roots. So k equals 0, k equals 1, k equals 2. So cube root of -1. So my r value is 1. So this would become the cube root of 1. Cosine of theta. The first one's always plus 0 because it's k is 0. So 2 pi goes away. Plus I sine. So there you go. For k is 1, cube root of 1. Cosine pi plus 2 pi over 3 plus I sine pi plus 2 pi over 3. K is 2, cube root of 1, cosine pi plus 4 pi over 3. So our three solutions would be 1, cosine pi over 3 plus I sine pi over 3. That's this one simplified. It would be 1 cosine pi, because that's 3 pi divided by 3, plus I sine pi. And this would be 5 pi over 3. All right, so then plot them. So pi over 3 is here. Pi is there. So we notice they are nicely evenly spaced about the origin. So there you go. The 8th roots of unity, huh? So that would be, let's see here, 1. So, which is the same thing as 1 plus 0i. So my r value is 1. My theta value is actually going to be 0. So here we go. There's a lot of work here. So k equals 1. K equals 0, 1, 2, so on and so forth. So when k is 0, actually we're going to kind of cheat this. When k is 0, it's going to be 1 out front because the 8th root of 1 is 1. And then it's going to be cosine 0 plus 0 over 8 plus I sine 0 plus 0 over 8. When k is 1, cosine 0 plus 2 pi over 8 plus I sine 0 plus 2 pi over 8. So this one is cosine 0 plus I sine 0. That's what this one simplifies as. The second one is pi over 4. So going from 0 to pi over 4, I'm counting by pi over 4s. The next one, I just need to add another pi over 4, which gives me to pi over 2. And then I just keep repeating that process until I have all of them that I need, because they're going to be evenly spaced, so the spacing has to be the same. So that's 4 roots. So the cosine, the next one would just be pi. Then it'd be 5 pi over 4. Then it would be 6 pi over 4, but that reduces. And lastly, the 8th root would be 0, 1, 2, 3, 4, 5, 6, 7 pi over 4. So those would be all of them. And if you plot them, 0, looks like that. 8 evenly spaced around the origin. Alrighty, and that is the end of that section.